بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Good morning, my dear students, and thank you for joining this lecture related to storing in cloud and big data. So, through this lecture, you are expected to be able to first explain the different manners for storing in cloud. Second, define the unstructured data known as the non-relational databases. Third, explain the usage search approach in unstructured data. Fourth, distinguish between relational and non-relational schemas. Fifth, define and discuss the big data concepts and challenges. Six, explain how the platform to manage big data. And finally, explain some cloud simulation tools or simulators such CloudSim. Now let's start by explaining the main techniques related to storing in cloud computing, and which can be summarized in three main approaches: object storage, file storage, and block storage. As you know, cloud storage allows you to save a large volume of data by transferring it via the internet to a remote server. In fact, before explaining in details these three approach, let's define what is cloud storage. In fact, in the field of cloud computing, data storage is carried out in a space or server managed and operated by a cloud provider. The storage location is rented by the client company. It chooses the formula offering a storage space adapted to the volume of data it wishes to preserve. So, the company purchases the right to store all kinds of data in the space made available by the cloud provider. Regarding the management, durability and accessibility of data via applications, it is the leader who takes care of it. Indeed, it happens that the same provider offers software allowing the collection, analysis, and management of resources stored in the server. Now, let's start by explaining and defining the first approach or the first model of storing data in cloud, which is the object storage. Object storage is a strategy for managing and manipulating data storage as discrete units called objects. These objects are stored in a repository and attached to files in other folders. So object storage combines the data that makes up files, then processes all relevant metadata before assigning them a custom identifier. This comprehensive metadata is associated with files, eliminating the hierarchical structure used in file storage, and then place it in a fixed address space called a storage pool. This metadata is essential to the proper functioning of object storage because it provides a deep insight into the usage and function of the data in the storage pool. In fact, object storage takes each piece of data and designates it as an object. So unlike files which are stored in folders, data is kept in different repositories where it is grouped together with associated metadata and a unique identifier to form a storage pool. Now let's highlight some benefits of object storage. So now that you know more about object storage, let's learn about its benefits. First, boosted analytics. So object storage is based on metadata as explained previously. So this level of classification allows for deeper analysis. Second, which is about unlimited scalability. So here there is no limit to the amount of data you can add. 3, accelerated data retrieval. Because of object storage categorization, structure, and lack of folder hierarchy, you can retrieve data much faster. Fourth, reducing cost. Because of object storage scale-out characteristics, so data storage is less expensive. And finally, optimizing resources, which means that object storage is not based on a file hierarchy, and metadata is fully customizable. So in fact, compared to file or block storage, it has fewer limitations. Now let's move to the second approach of storing, which is the file storage. File storage is the process of storing data in its complete form within folders organized according to a defined hierarchy. The process of saving files is similar to that of a filing cabinet. So you save data in a file, which you then place in a folder. This folder will probably end up in another folder, and so on, by creating a hierarchical series of directories and subdirectories. In fact, what is exactly a file system? This nested structure allows the computer to follow the different paths using the names of directories and folders. In this way, it's possible to quickly save or retrieve a file related to a particular folder. In other words, file storage is similar to a large digital filing cabinet. Just like a real filing cabinet, it's an ideal storage solution for structured data that follows a standardized format, such as the use of names, dates, etc. You can also use a non-premises file storage system accessible via one or more local hard drives or via a network attached storage known as the NAS. More and more businesses are also turning to online file storage by moving their stored files to the cloud. Here is some benefits of using file storage approach. First is about ease of use. So accessing files stored within storage is relatively simple. Hierarchical structures are commonplace in everyday life and on our own personal devices to the point of being intuitive. So no specialized training, coding, or other storage-related skills are required to use it. Second, which is about unification. Here, all stored files are stored independently and completely. It's not possible to break a stored file into blocks or split and store these blocks on different servers. So each file remains whole and unique, stored in a single location, and can be retrieved quickly and easily. 3, collaboration. The intuitive operation of the hierarchical structure allows authorized teams to collaborate easily, accessing and sharing the same files and folders stored on the network attached storage device over a network. 4, compatibility. Since file storage is so widespread and has been the basis of most basic storage management since the invention of the computer, most applications and operating systems are pre-configured to work with dedicated solutions. In most cases, integrating a file storage solution into an existing IT infrastructure is frictionless. 5, protection. So to ensure the integrity of your stored files, various controls can be deployed. Although these are usually built in initially. These include versioning controls to determine the correct version of the file to work on, and also to control who can access the data and audit change made. So this is what about the file storage. The last approach is about block storage. Block storage is a method for controlling data storage and storage devices in systems that require high performance, flexible data management, and robust security capabilities to protect critical information. Block storage stores data and divides the information into individual, equally sized blocks without hierarchical structure. The block storage system then stores the data block as a single address optimized for fast access and retrieval on the underlying physical storage. This flexible method is preferred by developers who develop applications because it allows the blocks to be split and formatted for fast and reliable access to data according to specific functional needs. Block storage is protected shortcut to data. Note that file storage requires an additional layer based on NFS or SMB file system to be processed before accessing the data. Here we have also some benefits of block storage. First, it's more efficient than other types of data storage because it allows you to store blocks in a single file. This means that there is no separate file for each block, which reduces file system overhead. Second, block storage reduces power consumption when using magnetic hard drives because the disks do not spin up at the same time. So, since there is no separate file for each storage block, the disk spin up only when the requested data needs to be read or written. Third, storage blocks can be flashed to disk asynchronously, which allows disk input-output operations to be optimized by grouping them together. This technique reduces system resource requirements because disk input and output operations are reduced, and the CPU, which is the central processing unit, is freed up for other tasks. Fourth, when it comes to block storage, there are many more options for data resiliency because block storage can provide self-healing capabilities beyond the capabilities of current file system-based storage. For example, block storage can provide redundant replicas stored in as many locations as needed across multiple regions. This provides much better data protection than traditional file system storage. For example, Oracle offers persistent and durable block volumes beyond the lifetime of a virtual machine, scaling up to 1 petabyte per compute instance. Now, let's talk about one of the well-known theorem used in particular in big data, which is known as the CAP theorem. The CAP theorem states that it's impossible to satisfy or guarantee the following three properties simultaneously in a distributed system. These properties are consistency, availability, and partitioning tolerance. What we mean by consistency? Consistency means that all clients or all users see the same data at the same time. For the availability, all users can read and write at any time since the system is able to respond to them at all times. For the partitioning or partition tolerance, if an individual node fails or individual nodes are no longer able to communicate with each other, here the system can continue to operate as a whole. As you can see, through the CAP theory, we can access two different kinds of databases. Non-relational databases, which known as in unstructured data, and also for the relational databases. Here we have some examples of different kinds of databases, relational and non-relational, such CouchDB, Cassandra, DynamoDB, MongoDB, HBase, Redis, and so on. Today, computer scientists rely on this theorem when creating a new distributed system and choose a basic model that focuses on two of these three properties. So according to the CAP theorem, groups of independent computers within a system can therefore be classified into three categories, which are the CA, including consistency and availability, AP, including availability and partitioning tolerance, and the CP, covering consistency and partitioning tolerance. Now let's explain in detail the non-relational databases, known also as the non-SQL databases, which mean not only SQL. Non-SQL databases are a non-relational data management systems that do not require a fixed schema contrary to the relational databases, which is easier to scale. They are particularly used to facilitate the storage of large quantities of data. Logically, they are therefore found in big data projects and development of real-time web applications, such as, for example, Twitter, Google, Facebook, and so on. Rather than using only SQL syntax to store and extract data, each type of non-SQL databases encompasses a wide range of technologies. In fact, there are four main types of non-SQL databases, and they can be key-value, column-oriented, document-oriented, and graph-oriented. Let's explain the first approach, which is a key-value. Key-value is the simplest type of non-SQL database. Each piece of data is stored as a key-value pair consisting of an attribute name, which is a key, and its corresponding value. In a sense, a key-value database works much like a relational database. But the main difference is that it only has two columns, the key and the value. For example, if we talk about a key as a country and a value, for example, as Saudi Arabia. In fact, this approach presents some advantage, such its simplicity, its scalability, it supports multiple value types such XML, JSON, and so on, its ability to speed up development, and this approach is ideal for databases where the data is not really related to each other. This is what about the key-value approach. Now, let's explain the second approach, which is the column-oriented databases. Unlike relational databases, which store and link data online, a column-oriented database is organized into a set of columns. This means that when you want to run analysis on a small number of columns, you can read these columns directly. And this allows you to avoid consuming too much memory by processing irrelevant data. So, columns generally group similar data and benefit from more efficient compression. And this is what makes them even faster to read. This type of non-SQL database therefore makes it easier to aggregate the value of a given column and is particularly popular for data analysis. A good point that unfortunately comes at the expense of consistency. So writing all the columns requires several events on the same disk. Here we have some advantages when using this approach. First, they can handle semi-structured data. The data is naturally indexed. This basic model is scalable. And on the other hand, this type of base is not suitable for relational data. Now, let's explain the third approach, which is related to document-oriented. This type of document-oriented non-SQL database stores, as its name suggests, data in JSON, for example, in BSON or XML documents. So here, document can be nested, and specific elements can be indexed for faster querying. In fact, documents can be stored and retrieved in a form much closer to the data objects used in applications. This means that this type of database requires less translation work. Well, document-oriented databases are popular with developers because they offer the possibility of reworking their structure as needed. So they are therefore more modular and allow the development of scalable applications, better able to adapt to the needs of their users. So this flexibility speeds up development because, in effect, the data becomes code. This approach presents also some advantage, such that the model is both simple and powerful. Second, it's more scalable. And third, it offers open formats. For the disadvantage of this approach, first, this database is not suitable for relational data. In other words, it's not possible to link data together. Second, queries are limited to case and indexes. Now let's explain the last approach, which is graph-oriented. A graph database focuses on the relationship between data elements. So each element is stored as a node, and the connection between them are called links or relations. In this type of non-SQL database, connections are first-class elements stored directly. While in relational databases, these links are implicit and use data to express relationships. A graph database is optimized to capture and search for connections between data elements. It therefore avoids the overhead associated with joining multiple tables in SQL database. On the other hand, very few systems can survive on graph queries alone. They are therefore generally executed in parallel with other more traditional databases. In fact, this approach presents some benefits or advantages, like its power and agility. Second, connected data is indexed locally. Three, their ability to provide ACID, known as the atomicity, consistency, isolation, and durability for real-time results. And finally, graph-oriented databases are often difficult to scale, even if they can evolve. Now, let's make a comparison between relational and non-relational databases in terms of some functionalities, such multi-server scalability, data structuring, power of SQL language, data schema, and transactions. Here we took some examples of relational and non-relational databases. For relational database, we took the example of MySQL. And for the non-relational databases, we took the data store. For the multi-server scalability in MySQL is limited to one main server for writing. So to have more writing power, you need a power server. In data store, multi-server is by default and there is no limitation. Here, load is easily distributed across multiple servers. For the data structuring, in MySQL, data are always very structured in tables. And it's very useful when you need a precise structure. For data store, it's suitable for data in a tree structure, such, for example, XML, JSON, and so on. For the power of SQL language, MySQL allows you to perform complex and precise queries, which is sometimes quite slow. And for the data store, it allows you to perform only simple but fast queries. Regarding data schema, in MySQL, the schema is restrictive. So you absolutely have to fit the data into the boxes provided. And the main advantage is that everything is always neatly stored. Contrary to the data store, where the schema is not restrictive. So you can do whatever you want, store as you want. So here you have to manually check if everything is stored properly. The last functionality, which refers to transactions. Transactions in MySQL are strict, which means that data are immediately recorded and updated. For the case of data store, transactions are possible, but it requires more work. And data may be recorded with a slight delay. Okay. Now let's explain the concept of big data. So before entering in details about this concept, here we have some statistics regarding the collected data. And this is what happened in an internet minute. The statistics is for 2021. Here we have some examples about some data sources, such LinkedIn, such Netflix, such Facebook, such YouTube, such Instagram, such TikTok, and so on. For example, for Facebook, we have about 1.4 million scrolling. For LinkedIn, we have about 10,000 connections mod. For Netflix, we have 28,000 subscribers watching. For Snapchat, we have about 3.4 million snaps created. Also for Messenger and WhatsApp, we have about 70 million messages sent. For Twitter, which is known as the X platform, in which we have about 200,000 people tweeting and so on. So can you imagine the huge number of data created in a minute? So here, the main concern is about how to store, how to process, and how to analyze these huge quantities of data. So, big data analytics refers to collecting, processing, cleaning, and analyzing a large data set to help organizations operationalize their big data. Let's explain how to collect data and to store them. So data collection looks different for every organization. With today's technology, organizations can gather both structured and unstructured data from a variety of sources, from cloud storage to mobile applications to in-store IoT sensors and beyond. In fact, some data will be stored in data warehouse where business intelligence tools and solutions can access it easily. Raw or unstructured data that is too diverse or complex for a warehouse may be assigned metadata and stored in a data lake. For the processing step, so here, once data is collected and stored, it must be organized properly to get accurate results on analytical queries, especially when it's large and unstructured. Available data is growing exponentially, making data processing a challenge for organization. So one processing option is batch processing, which looks at large data blocks over time. In fact, batch processing is useful when there is a longer turnaround time between collecting and analyzing data. We have another techniques known as stream processing. Stream processing looks at small batches of data at once, shortening the delay time between collection and analysis for quicker decision making. Stream processing is more complex and often more expensive. Now, let's explain the third step, which refers to analysis. So before talking about analysis, it's important to have a cleaned data. So data, big or small, requires scrubbing to improve data quality and get stronger results. All data must be performed correctly, and any duplicative or irrelevant data must be eliminated or accounted for. Now, how to analyze data after pre-processing phase or clean phase? Getting big data into a usable state takes time. Once it's ready, advanced analytic processes can turn big data into big insights. Some of these big data analysis methods include: first, data mining source through large data sets to identify patterns and relationships by identifying anomalies and creating data clusters. Second, predictive analytics uses an organization's historical data to make predictions about the future and identifying upcoming risks and opportunities. Third, deep learning imitates human learning patterns by using artificial intelligence and machine learning to layer algorithms and find patterns in the most complex and abstract data. So, big data analytics cannot be narrowed down to a single tool or technology. Instead, several types of tools work together to help in collecting, processing, cleaning, and analyzing big data. Some of the major players in big data ecosystems are very useful to make storing, processing, analysis of big data successful. Okay. Here, let's say one of the most known and the most useful platforms using in managing big data, which is the Hadoop. In fact, Hadoop is an open source framework that efficiently stores and processes big data sets on clusters of commodity hardware. This framework is free and can handle large amounts of structured and unstructured data, making it valuable mainstay for any big data operations. Now, let's explain the main challenges in managing or analyzing big data, which is known as the 5V, including volume, veracity, velocity, value, and variety. We often talk about the 5V to, in fact, describe big data. This corresponds to volume, veracity, velocity, value, and variety. What we mean by volume? Volume, in fact, big data is characterized by a very large quantity of data that is collected and then analyzed. What we mean by velocity? The data here is collected and processed almost instantaneously. For the variety, the data retrieved is of a very large variety since it comes from different sources and has various forms such text, images, videos, sounds, etc. For the veracity, big data is characterized by the reliability of the data collected, even if this is threatened by the diversity of data sources. And finally, the value. The data must be selected or stored in order to keep those that will deliver real value. That is to say, real added value to organizations or companies. Now, let's explain the main elements making big data management successful. As you know, we are familiar with our laptops or desktop computers, which have three main components to do data computations, which are hard disk, memory, and CPU, which is the central processing unit. The data and cards stored in the hard disk have specific features such as slow to read and write and large capacity of around a few terabytes in today's market. Memory is fast to read and write, but with a small capacity in the order of a few dozens of gigabytes in today's market. And for the CPU is where all the computations happens. Okay. For statistical software, such for example, R, the amount of data it can process is limited by the computer's memory. The memory of computers before 2000 is less than 1 gigabyte. The memory capacity grows way slower than the amount of the data. Now, it is common that we need to analyze data far beyond the capacity of a single computer's memory, especially in an enterprise environment. Meanwhile, as the data size increases, to solve the same problems, such for example regressions, the computation time is growing faster than linear. And using a cluster of computers become a common way to solve a big data problem. So a cluster of computers can be viewed as one powerful machine with memory, hard disk, and CPU equivalent to the sum of individual computers. It's common to have hundreds or even thousands of nodes for a cluster, as shown here in this figure. In the past, users need to write code to distribute data and do parallel computing. Fortunately, with the recent new development, the cloud environment for big data analysis is more user-friendly, as data is often beyond the size of the hard disk. The dataset itself is stored across different nodes, for example, through Hadoop system. So when doing analysis, the data is distributed across different nodes, and algorithms are parallel to leverage corresponding node CPUs to compute. So, as summary, to solve or to find solutions regarding big data challenges, we have to provide or to support some solutions. For example, using cluster of computers, using the distributed file systems, and which will be explained, inshallah, in the next lecture by or through Hadoop. And also, it's important to use machines with high performance based on GPU, and also interacting with other kinds of databases, such the non-relational systems, which is known as the non-SQL database. So this is what we have for this lecture related to storing and big data chapter in its first part. Thank you for your listening, and Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.